Okay, in this video, we're going to study how to use the two given functions, fx and gx, to define the composition of fx and gx. Now, this is the definition. The composition of the function fx and gx is defined by this. So this is read as the composition of fx and gx, and it equals f of gx, and the domain of this function is all x in the domain of gx, such that gx is in the domain of fx. Now, this may be a little bit confusing, so let me use this graph to show you how to understand the definition of the composition of functions. So here we have x, which is our input, and if we use x as input of the function g, so we're gonna generate a gx, we're gonna generate a number gx, and then now we use this number we generate as a new input, as input of the function f. So we're going to generate another number, and this number is called f of gx. So by doing this, the domain of the function is going to be this number x. But we have to be careful, because sometimes the number x is generate a gx, but the gx cannot be used as the input of f. So in that case, that x will not be the domain of this composite function. So for example, if we consider these two functions, gx equals x minus 1, and if the fx equals 1 over x. Now, think about what will happen if I use 1 as my input. If I use 1 as input, now the gx will generate the number 0, which is okay, right? So that means 1 is in the domain of gx. However, if we use this number 0, which is generated by 1, if we use this number 0 as the input of f, we're gonna generate 1 over 0, and this is undefined. This is undefined. So therefore, since 0 cannot be used as input of f, that means the 1 cannot be used as input of this composite function. So in this example, 1 is not in the domain of this composite function, even though 1 is in the domain of gx. Now, so this is the idea of the idea of the domain of the composite function. Okay, now in the next videos, I will show you how to do this step by step when we are given two functions.